Hey there, it's Dina from idon'tgetittutoring.com. In this video, I will be going over basic trigonometry. Let's get started. Trigonometry might sound a little scary and it's a pretty long word, but trust me, it's actually really simple. So, trigonometry. Let's define it first. Trigonometry. So, trigono, the beginning of the word means trigono in Greek. And trigono means triangle in Greek. So it's basically the study of triangles. And metro, means measure in Greek. So we're basically measuring triangles. But it's not easy as taking a ruler and just measuring the side lengths of a triangle. It's more about finding common ratios, not common ratios, but finding ratios in triangles and seeing what the lengths could tell you about the triangle. Trigonometry is often and usually done with right triangles. And basically what a right triangle is a triangle with a right angle. And what's a right angle? An angle that equals 90 degrees. Okay, so yeah, it's as easy as that. Now let's define a few things before we start working with these right triangles. So in a right triangle, we have our right angle and three sides. So this long side, this is the longest side in the triangle. This is called the hypotenuse. It's always across from the right angle and it's always the longest side. Next, these two sides here, these are called our legs. These are the legs of the triangle. Obviously right here, it's our right angle. And these here are our vertex angles. Let me find a different color. These angles have the same measure, 45 degrees. Why is that? Because the angles inside of a triangle add up to 180 degrees, 90, and then no, I apologize. This is for isosceles right triangles. So if the legs are are equal length, like I depicted here, they're both like red, like the same length, then those angles are equal to each other. That would be an isosceles right triangle. But in other right triangles that are not isosceles with differing leg lengths, that means that the angles are different lengths. So ignore that. Now, about these legs, when we focus on a point, right? Let's say we labeled this right triangle point DEF, triangle DEF. This yellow line, the hypotenuse, will always be the hypotenuse to F and E and D. No matter which point on this triangle you're thinking from, hypotenuse stays hypotenuse, but the legs can be considered adjacent to a point. And what does adjacent mean? Next to. So for example, if we're thinking about point F, right? We're thinking, okay, there's two sides of the triangle touching F, right? Segment DF is still the hypotenuse to F. Even though it's adjacent, even though it's next to it, it's not adjacent. Legs can be adjacent, the hypotenuse stays the hypotenuse. But EF, that is adjacent. Now let's take a look at E. DE, okay, DE is adjacent to point E, and FE is adjacent to point E. Point D. DF is the hypotenuse, and DE is adjacent. Just wanted to clear that up before we continue. So, let me clear some of this. And now let's get to the most important thing. SOHCAHTOA. SOHCAHTOA is an acronym for helping students, or just helping anyone in general, remember trigonometry. That's a long word. Trigonometric ratios. So, there's three things that are important when doing this: secant, cosecant, tangent. A secant is equal to the opposite over the hypotenuse. Cosecant is equal to the adjacent over the hypotenuse. And the tangent is equal to the opposite over the adjacent. Okay, so you're going to be asked to find the secant, cosecant, and tangent of points, not segments. You can't find one of a segment, but you could find one of a point. So let's start with this triangle right here that I have. Let me add some side lengths to it before we continue. Okay, now let's find the secant of point D. The secant of point. What am I saying? I apologize. It's not secant. It's sine and cosine. What am I? I am thinking about geometry. Yes, this isn't geometry, but I am mixing up the terminology. I apologize. This is sine, cosine, and tangent. Yes, sine, cosine, sine. Not secant. What was I thinking? I apologize. Sine, cosine, and tangent. So we are looking for the sine of point D. And the notation for these, by the way, is sine, cosine, and tangent. This is how you're going to see them on your calculator. Okay, so let's find the sine of point D. So with this acronym, right? So secant is opposite over hypotenuse. You could also write it as SOHCAHTOA. That's also a way to write it, so you remember like the way the fractions are. So we're finding the opposite side of D. Opposite side of D is EF, and EF has a side length of 4. And that is over the hypotenuse. right here, which is 5, longest side of the triangle. So that would be 4 over 5. That's the sine of point D. Let's find the cosine now. The cosine of point D would be the adjacent side to it, and that would be over the hypotenuse. So, adjacent to point D are 2 sides, right? But remember what we said. There's a hypotenuse next to it, and there's an adjacent side next to it. So, we are going to do the adjacent, which is 3, over 5, the hypotenuse, and that's the cosine. And now let's find our tangent to point D. Our tangent is the opposite over the adjacent. So we said the opposite is a length of 4, and we said the adjacent is a length of 3. So that would be our tangent. And there we go. It's as easy as that. As long as you remember this acronym right here, SOHCAHTOA, you are golden. You know pretty much, you know a lot about trigonometry if you know SOHCAHTOA. It's very simple to get a grasp of, especially because of this acronym. So that concludes our video for today. Thank you so much for watching, and I hope you found this helpful. Now you know a lot more about trigonometry. Thank you for watching. Bye!